In this video, I'm going to solve this question on volume integral, still on vector calculus, vector analysis. First of all, let us see what volume integral is. If V is a closed region bounded by a surface S, and F is a vector field at each point of V, and on its boundary surface S, then this is the volume integral of F throughout the region. And volume integral is the volume integral of f dv is this. We have triple integral. Okay, z1 to z2, y1 to y2, x1 to x2 of what? F dx. Okay, this is the pattern. Dx, dy, dz. Sometimes we write it like this. The volume integral of f dv is the triple integral. We start with x1 to x2, y1 to y2, z1 to z2. So we now have this. The z, you get it, then dy dx. So let's solve this question. Let's evaluate the volume integral of f, where v is the region bounded by the planes x is equal to 0, x equal to 2, y equal to 0, y equal to 3, z equal to 0, z equal to 4, and f is the vector xyi plus zj plus x squared k. Remember, for volume integral, we have the integral of f is this, z1, z2, the integral from y1 to y2, the integral from x1 to x2 of f dx, dy, dz. Alright, so let's go ahead. So the integral from z1 to z2, that's from 0 to 4. From 0 to 4. y1 to y2 from 0 to 3. Then x1 to x2 from 0 to 2. F is the vector function xyi plus zj plus x squared k dx, dy, dz. So let's evaluate this multiple integral. This is how to evaluate multiple integrals. The integral from 0 to 4. The integral from 0 to 3. So I want to integrate this. I'll take this first. I'm integrating this with respect to x. Integrate the vector function with respect to x first of all. Then we apply the limit of integration on the result. So if I integrate that, I'll get, integrate this with respect to x first. Y will be taken as a constant. So if we integrate x with respect to x, that's x squared over 2. So we have y x squared all over 2 times the I. This term does not contain x, so we consider it as a constant. So if we integrate a constant with respect to x, we are going to obtain zxj. We'll add x to it. Here, let's integrate x squared with respect to x. That will be s cubed all over 3k. So we now have dy dz. dy dz. So the integral is from 0 to 2. From 0 to 2. Let's evaluate it. 0 to 4, 0 to 3. Plug in 2 for x first. And then we'll plug in 0 for x. So 2 enters here. That will be 2 squared, which is 4. 4 over 2 is 2. So we have 2yi. 2 enters here, we have 2z. That's 2zj. 2 enters here, we have 2 to the power of 3 is 8. Alright, so 8 over 3k. If you plug in 0, that's we're going to say minus. We'll now plug in 0 for x. Everything will become 0 at the end. Check it. 0 here is 0, here is 0, and here is 0. So there's no need to just write a minus since it's going to give us 0. Let's just proceed. We have dy dz. So let's evaluate this integral. The integral of this function with respect to y from 0 to 3. Okay, so we have the integral from 0 to 4. Let's integrate this now with respect to y. Integrating this with respect to y, we have 2y squared upon 2i. 2z is the constant, so if we integrate it with respect to y, we have 2yzj, right? If we integrate 8 over 3k with respect to y, that's 8y over 3k. From 0 to 3, we are left with what? The z. So let's evaluate 2 cancel 2. Plug in 3 for y, that's 9. 3 squared is 9. Plug in 3 for y, that's 6zj. Plug in 3 for y, 3 will cancel 3, we are left with what? 8k. Then I'm supposed to say minus, I'll substitute 0 for y now. But if I plug in 0 for y in each of these terms here, it will give me 0. So that's out. There's no need to plug in 0 since it's going to give 0. Then the z. So let's now integrate this with respect to z and evaluate the integral from 0 to 4. So what would that be? Integrate 9i with respect to z, that's 9zi. And this will give us what? 6z squared all over 2 times j. And this will give us 8zk from 0 to 4. So let's plug in 4 for z. 4 here, that's 9 into 4i. This is 3. So 3 into z is 4. That's 4 squared j. Plug in 4 here, that's 8 into 4k. Then minus, I should plug in the what? The lower limit now for z, but it will give me 0 also. So no need for that. I can see that 4 is common to all of them, all the terms. 1, 2, 3, there's 4 in each. So I can factor 4 out. I'll be having 9i left here. If I bring 4 out here, I'll be having 3 times 4. Since 4 is to the power of 2, so if I factor out 4, I'll be having just 4 to the power of 1. Times 3, that's 12. And what will be left here? Just 8k. So this gives the volume integral. This is the volume integral of f.